Hi. So just, yeah, I have a lot of stuff to go through, so I hope that you've read the summary on the website. Quick disclaimer before we get started. Most of my experience is with games with file systems, so games on disks or downloadable PC games. That's not to say that none of this is applicable to games on cartridges or even things that aren't games. I hope that the techniques are general. First of all, why is this something you want to get into? Well, from reasons from least useful to most useful. Least useful being showing off. These are some cool websites I like. NoClip.websites is a place where you can fly around the levels from some 3D games. Steve Gunner is a YouTube channel that does spoofs of video game soundtracks. And a lot of their sources are from actually the game data itself. Second reason is modding. If you get a good enough understanding of these data formats, you can actually convince the program that data that you make is what it expects, and you can put your own content in there. Another reason is engine recreation. So a lot of old games don't run so well on modern systems anymore. So some enterprising people have come upon themselves to rewrite them from scratch, given enough, good enough understanding of the formats they use. And finally, the most useful thing to get out of this is learning. You learn a lot about how these game engines work, how they're put together, the engineering that goes behind them, and it's valuable information for even your day-to-day programming. What have I done with this? Well, this is supposed to be Mario doing a victory pose, but let me know after the talk if you're good with matrix math. Before you get started, even doing this, you'll want to do some research, because the older and more popular the game is, the more likely someone's already done the work for you, or at least most of the work. So here are some search terms. Another thing you want to do while you're doing this work is keep in mind the context. So what engine does it use is useful because engines generally use the same format. So if you can look up another game that uses the same format, then you already have some of the work done for you. What platform was it made for? That can determine things like endianness, which we'll get to later. And who developed it? This actually goes back to the first bullet point, because even if they don't say they're using a specific engine, if a developer made 2 games in quick succession, it's likely that they at least had some code in common. Another thing you can get out of who developed it is like the environment it was developed in. Like a lot of Japanese developers at least used to like to use shift-JIS instead of Unicode. So if you've never seen a hex editor before, this is what it looks like. Left column is your position. Middle column is the actual contents of the file in hexadecimal. The right column is the same contents of the file, just interpreted as ASCII, with little dots for things that aren't printable in ASCII. And then on the bottom there is, oh, right, I should be highlighting these. That's the position, that's the contents, that's the ASCII, that's the, I call it the decode view. It's the contents that are right next to the cursor, just interpreted in different data formats. Mine doesn't have a string view, but some others do. So, floating point, things like that. I'm going to give you this example now. By the end of the talk, hopefully I'll have given you enough information that you can figure out what this actually is, or at least what type of file it is. And I'll give you 2 little hints now. One is these 2 columns, and then the other one is the numbers on the right have a certain pattern to them. Give you a few seconds. Integers are pretty straightforward, but they can have 2, you have to keep 2 interesting things about them in mind. One is their endianness. They can go either way. As for why you'd actually want something a little endian, go ask Intel. They can also be signed or unsigned. That's not what I mean. Signed or unsigned, that actually means whether or not it has a plus in front of it or a minus in front of it. Basically, that means if you see a number starting with a bunch of Fs in hexadecimal, that's less likely a really, really big number and more likely a small negative number. Floating point is harder to read in hex view than integers. But two hints I can give you. One is be looking out for that 803F or 3F80, that second line in the table there, because 1.0 is really, really common. And in fact, as a kind of extension to that, as humans, we like to use human-sized numbers. So the exponents, those last two, or that last byte, is going to be common for a lot of them. And if you pop it into the decode view, and you see something like 3 times 10 to the 38 or something, or times 10 to the 200,000, you know, these game developers don't normally need to count the number of cows under the sun, so they'll usually be human-sized numbers. As for where things actually go in the file, the obvious answer is to just put one thing after another, like in a C struct in memory. So here's an example of that. But it gets a little bit more complicated when you have arbitrarily sized arrays or complex data types. The one way to do that is just to have, one way to do a dynamically sized array, for example, is to have just the number of the thing and then that number of things immediately following. But there's some other things you can do, for example, pointers. In a real running program, you can just allocate some memory and have a pointer to it. In a file, you actually have to have it all in that linear space. But you can still do the same thing. So here's an example. Ignore the top part, that's the header. But you see immediately after the header, we have these two numbers, which are little endian, but if you flip it around, actually point to other positions in the file. So that way, this example is showing you, at this point in the file are the, I think it's like positions, and at this point in the file are the vertex normals, something like that. Another way you can have things laid out in the file is with chunks, not that kind of chunk. And this is more common for really complex formats like documents or movie files that need to have a whole bunch of different types of things all in one file. Usually you'll have a 4-byte or 8-byte or however many byte identifier for what type each chunk is, and then another few bytes saying how long that chunk is. So you can see each of these two chunks is 40 bytes, and that exactly lines up with 4 rows in our hex dump here. So the example that I gave you at the beginning, I'll give you the hints again. That is this column. And actually, I'm going to give you a little bit more information that all of these in the left column are floating point numbers, and everything on the right side are integers that are increasing. Now, anybody have any ideas as to what this is more specifically? Mesh. Yes, this is a 3D mesh. Nice job. Each of those floating point numbers is a 3D position, and each of those indices is, well, numbers is an index into these positions. You get 3 positions, and they make a triangle, and you get a mesh. Yeah, so one thing I want to point out is the numbers on the right are generally increasing because that's just the way indices that are automatically generated tend to be laid out. Other small things, indices I just talked about. Opcodes we heard about in earlier talks, but they're useful for programs. They're also useful for things like music. Images are really fun in a hex editor because you can just resize it to be as big as the image, and you can see it in the hex view. Audio samples tend to go up and down. Encryption and compression are really easy to recognize, but really hard to decode because they both kind of have this similar goal of making data look random, right? Like compression needs to get as much data into as little space as possible, and encryption, its actual goal is to make it look random. So I don't have any good solutions for that right now. Other techniques you can use, other than just looking at the hex and figuring it out from there. The first bullet point, in the last example, I showed you we can recognize the different data types, and then you might look at the beginning to see if there are any pointers to that, or you can look the other way. If you look at the beginning and there are things that look like pointers into later in the file, maybe you can look at where those point to. The next 3 bullet points, the ones that start with a C, are useful if you already have a program that can go one direction or the other for comparing with your own program. The second to last one, debugging, is useful if you have a debugger or also an emulator. And then as a last resort is actually reversing the executable. And that could be a whole separate topic. That could actually be like a college course, not a 10-minute talk. So I'm not going to go into it here. And the other reason I consider it my last resort is in the first slide I talked about engine recreations. if you, how do I put this? If you look at the actual assembly code of some executable and you try to recreate it, you can't prove that you're not just copying it, so that gets to legally gray. If there's one thing I want you to take away from this talk, it's that there's no such thing as an unknown, unstructured blob of binary data. Everyone, I mean, these files were written by people, right? People put those numbers there for a reason, and if you're adventurous enough, you can find out why. Here's some resources. Thanks for coming to my first ever tech talk.